Hi guys, so hope you're doing great. Today we'll be discussing the solutions for CodeChef Starters Division 3 first 4 questions. So without any delay, let's jump into the questions. Also, make sure you first go to the questions, read the questions, attempt them before watching the solution. Let's begin. Alright, so let's begin with the first question. So the first question is legs on a farm. After a long and fulfilling career, Chef has decided to retire to the farm out in the countryside. This farm has several cows and chickens, but Chef doesn't know exactly how many of each are there. He can only see that there are n legs in total across all the animals. Note that each cow has 4 legs and each chicken has 2 legs, and it is guaranteed that n is even. With n legs in total, what's the minimum possible number of animals that can be present on a farm? So there there is a farm given to us, let's say, and in which the chef is owning, let's say, X cows and Y hens. Now he can only see that there are n legs, and it is given that n is even, which means n percentile 2 is equal to 0. Now he wants us to find that, find the value of the total number of animals such that it is minimum possible that are present on the farm. So when can I say that I'll get total number of animals as minimum? So if there are, let's say, n is equal to 8, that is the chef can see 8 legs. If there are 8 legs, then one possible combination can be I have one cow and the remaining 4 legs can be 2 hens, or I can have 2 cows and 0 hens. Now, in this case, I can say that the number of animals is 3, and in this case, I can say that the number of animals is 2. Among these both, what should our answer be? Our answer should be minimum possible number of animals, right? So, which is minimum? 2 is the minimum value. Now, the question is, how am I going to get what are the possible cows and what are the possible hens such that I can have this value of total number of animals as minimum? So, a simple way would be, if there are n legs and if there are x cows, then the number of cows should obviously be n by 8, right? Sorry, n by 4, right? Because if you are considering all the legs as cows legs, then there can be n by 4 cows. Now otherwise, if you are saying that y hens are going to be there, then how many by n, what can you say about y? Y is going to be simply n by 2. Since you want the minimum possible number of animals, initially you can consider that you need all the cows first, and whatever are the remaining legs, now that remaining legs is going to go to hens, right? So firstly, I'm going to take this out for sure. So my number of cows is going to be n by 4. Now if my n is something like 10 or 14 or some other value that is not divisible by 4, then what would be left out? In this case, 8 8 would be the multiple, and the left out n will be 2. In this case as well, 2. Otherwise, if you put 2 more legs, you are going to get 12. For 14, if you put 2 more legs, you are going to get 16. So you can see that if n by k, or simply if n percentile 4 is equal to 0, then all the legs will make only my cows. Now, if n percentile 4 is not equal to 0, what can you do? Simply, whatever are the 2 legs, those are going to go for the chicken. And do you need to again do whatever is the n percentile 4 by 2? Not required, right? So, if my n percentile 4 is not equal to 0, then definitely I know that there will be only 2 more legs left. And if my n percentile 4 is 0, it means that all the legs are cow's legs. So what can I finally say about this? Finally my answer is going to be n by 4, which denotes how many cows are there, plus if n percentile 4 is equal to 0 or not. Now if it is 0, do I need to add anything to my solution or to my answer? No, right? No. Now if there are, I mean, if there are remaining legs after giving all the legs, or after assuming all the legs as cow's legs, then I need to add only one animal, saying that these two legs are going to be a hen's legs. So final answer is going to be this much. Now this was all based on whatever was the description of the question. So for safety purposes, like if n is some bigger value, let's once check out the constraints as well. So in the constraints, if you see, uh, n is nothing but simply in between 2 to 2000. So if it were 10 power 18 or something like this, that is a value greater than 10 power 9, then you might need to use a long while storing the n. So make sure you read the constraints all the times, and in the constraints you also specified that n is even, as specified in the question previously. The sample outputs as well. If you explore the sample outputs, there are, if n is 2, then I can simply only have one hen. Now, if n is 2, what would the value of 2 by 4 be? It would be 0.5, and 0.5 in terms of an integer becomes 0. That is whatever is the integral part. So 2 by 4 plus 2 percentile 4 equal to 0. What is 2 percentile 4? It would be 2. So is that equal to 0? No. Hence, which value will be considered? 1 is going to be considered. Hence, the value for this is going to be occupied as 1. So the final answer is going to be 0 plus 1, which is nothing but our expected output. Likewise, if 4 is my n, then n by 4 is going to give me 1, n percentile 4 is going to give me 0. Hence, my final answer is also going to be 1 plus 0, 1. And if my n is 6 in that case, if my n is 6, what would n by 4 be? 4 ones are 4, and the remainder would be 2. So n by 4 is going to give me 1, and n percentile 4, that is 6 percentile 4, is going to give me 2. Since it is not equal to 0, what would the considered number be? My considered number would be 1. So what are we using here? We are simply using a ternary operator, and that's how finally our answer turns out to be 2. Hence we can see that all the expected outputs are same as whatever our logic gives. So without any delay, let's start coding it. All right, so let's start with the code now. Now this is my default template. You can use the set template option, which saves your whatever template code you want to start your problem solving with. So in CodeChef, since most of the questions are of this format, that is three test cases, without any time waste in that part, I simply took it as a template. So now let's quickly check what is the input format. The input format is first line of input contains single integer t. So we are scanning t, and then first and only line of each test case will contain n. So inside every test case, I'm going to get only one n. So n is equal to scan dot next int, which will take in my n. Now with this n, I know what is the answer. So answer is going to be whatever is the number of cows plus whatever is the number of hens. So what is the number of cows going to be? Number of cows is simply going to be n by 4, and the number of hens is going to be whatever is the n percentile 4 value that you get, that is after giving all the legs to cows, what are the minimum remaining, what are the remaining legs. Now if this value is going to be equal to 0, then I need to consider this number of hens as 0, else I need to consider it as 1, and that's it. So I now have the number of cows and number of hens. My answer is going to be the sum of these both. So C plus H. Let's quickly submit it. All right. So it is same as the expected output. Let's quickly submit it. Correct answer. All right. Let's quickly move on to the second question. So the second question is maximum alternating sum. He says that the alternating sum of an array A of length n is defined to be summation of I equal to 1 to n minus 1 power I plus 1 into A of I. So he also gave what is the expansion of this expression, whatever he gave. The expansion is going to be simply a1 minus a2 plus a3 minus a4 plus so on until minus 1 power n plus 1 an. So with this, one thing is clear until now, that he is using a one based indexing. So usually we use zero based indexing for arrays, right? That's how we start array iteration from zero. But here he starts from a1, which means he's using a one based indexing. So one thing is clear, that he's using a one based indexing. Now you're given an array containing n integers. You can rearrange this array however you would like. So let's just highlight this point for a bit. This is going to help us a lot in the solution. You need to find what is the maximum possible value of this alternating sum after rearrangement. After rearrangement. Now we are given the freedom of rearranging the array. If I'm allowed to rearrange the array and I need to get the maximum possible value of this expression where I can find negative elements, ideally, what should be my rearrangement as? My rearrangement should be something like, it should consider all my max values as positive numbers, right? If not all, no, here I can consider only, let's say if there are n values, I can consider only n by 2 values as maximum, right? So if not all values, the half of its values, if they are maximum, then whatever is the sum contributed by them is also going to be maximum. Now, by default, I need to decrease whatever are the remaining values from this sum. That is pretty understood and pretty clear. So let's quickly jump to what is given to us in the sample input and output. So if you see in the sample input, he gave us a case 3, 1, 2, 3. No, in 3, 1, 2, 3, that is 1, 2, and 3. If you do not consider rearrangement, what would your answer be? If you do not consider rearrangement, you would add 1, then subtract 2, add 3. What would your answer be in this case? 3 plus 1, 4, minus 2, 2. But then he gave the expected output as 4. Why? Let's look into it now. So I was given the freedom to rearrange the values, which means now if I consider this negative value as minimum as possible, I'm going to get my sum as maximum, can I say? So what is the possible minimum value from here that needs to take the place of this? A simple conclusion can be saying that 1 could be that minimum value. Now if you are going to decrement 1 and if you are going to add 2, what would your answer be in that case? 3 plus 2, 5 minus 1, 4. This is how we are getting the output as 4. And the rearrangement we are considering is something like 2, 1, 3. This is rearrangement. Let's move on to the next question, which is 5, 5, 5, 5. Now, whatever rearrangements you assume will give the same output, right? Because all are 5s. Even if you put 1 5 there, 1 5 here, it doesn't make any sense because the output value is going to be the same. And what would be the output value? It would be 5 plus 5, 5 minus 5 plus 5 minus 5, which would be 0. Then the next case is going to be 3, 1, 4, 1, 5, 9. Now, what are all the maximum values I can get? I mean, what are all the n by 2 maximum values I can get from this? The n by 2 maximum values I can get is first considering the highest value, then I can also consider the second highest value, then I can also consider the third highest value. Since n is 6 over here, I can consider 3 values at most, which will give me 9 plus 5, 14 plus 4, 18. Now, whatever is the remaining, can I say that I simply need to decrease this from the answer? Right. So, what is going to be the sum of the remaining numbers? 3 plus 1 plus 1 is 5. If I decrease 5 from 18, what would be the answer? 13. And that's how we are getting 13. So, does a rearrangement matter, or are we making use of the rearrangement particularly? No, right. What are we doing to get the answer as maximum? I need to simply consider what are the n by 2 maximum values I can consider. Now, what if there were, let's say here we find even number of values, right? What if there were odd number of values, something like 3, 1, 4, 1 and 5? Now, in this case, what should your answer be? According to our logic, that is considering the first n by 2 maximum values, there are 5 numbers and 5 by 2 would be obviously 2. But then if you look at the expression, it is a1 minus a2 plus a3, and if you say there are 5 numbers, the expression would come out to be a1 minus a2 plus a3 minus a4 plus a5. So after adding the two maximum values, I have the, what can you say, you have the freedom of taking in the third maximum value as well. So how are you going to consider this third maximum value? You found the 5 by 2 to be 2.5, and in terms of integer it would come out to be 2. So how can you make sure that you are considering three values in this case? And where else will you consider three values? If my n is 6, so how can I make my 5 to 6? A simple solution would be, if my 5 is, sorry, if my n is even, simply perform n plus plus. What would this do? This is going to make my 5 as 6, which means 6 by 2 will make you consider 3 values. Now, else do you need to perform anything? No, right? If you, if my n is odd here, my bad. So your n is odd here, that is 5. If your n is odd, perform a n plus plus simply, which will get you to 6, and 6 by 2 is going to give you 3. Now else means n is even. If n is even, do you need to perform anything, or do you need to worry about the n by 2 value? No, right? You'll directly get what is the n by 2 value, because if you consider 6, it would be 6 by 2, which is 3. That is making you consider the three highest values. So I need to somehow consider all these highest values first, n by 2 highest values. What could a simple approach be? I can sort the given array. So if I sort the given array, what is going to be my answer? If I sort the given array, my answer is, my array is going to look like 1, 1, 3, 4, 5, 9. Now I can simply iterate from the last element until what position? Until n by 2 position. And I need to make sure if n is odd, I'm going to increment my n as well. So without any delay, let's convert whatever logic we discussed to code. All right. So starting with the code. Now initially I have my template ready with me. I need to read the input format. What is the input format? The first line of input will contain single integer, and each test case consists of two lines of input. First line of each test case will contain single integer n, that is the length of the array, and second line will contain space separated n integers. So
Now for firstly take the array int array equal to new int n. Then for int I equal to 0, I less than n I plus plus, to scan array of I equal to scan dot next int. Now after scanning the array, what do I perform? I understood that I need to be performing sorting operation. So there is an inbuilt sort in Java, arrays dot sort ar. I simply need to pass in the array. Likewise, you have inbuilt sort functions for C++ and Python as well. So you can make use of the same. Now, what do I do next? As discussed, if my n value is odd, even in that case, I need to consider one value extra into my answer. I mean, one positive value extra into my answer. So to make that happen, what did I simply do? If my n is odd, I'm incrementing my n value. So how do I find if n is odd? A simple way could be n percentile to equal to 0. But a more easier way and faster way you can say is a bitwise operation performing bitwise AND. So by performing bitwise AND, this is going to simply check the last bit. Now, if you consider binary representations, the binary representation of an odd number will have last bit as set, and a binary representation of even number will have its last bit as unset. That is, set means 1, unset means 0. Now, if my AND operation is going to give me 0, it means that my last bit is unset. So if my last bit is unset, do I need to perform anything? No. If my last bit is set, then it means that it is an odd number, hence I need to perform n plus plus. Now after performing n plus plus, what do I do? I need to know how many elements to be considered. So let's take consider equals to n by 2. And how do I start? How do I start considering the maximum numbers? I can simply iterate from the last index. So for int I equal to n minus 1, can you take now? No, right? Now here n value might be increased. So what we can do is we can first take the consider value, and if n is odd, you can increment the consider value by 1, because you know that even for an odd number you are going to get one value less. Hence, increment it to make it sufficient or to make it work for the solution. Now int I equal to n minus 1. With this, my n value will remain unchanged because I am not reassigning n. With this, my n value will be unchanged because I am not reassigning with n. Okay, so int I equal to n minus 1. I should be greater than or equal to 0. I minus minus. Most people make a mistake at this I minus minus. Make sure you do not make the same mistake. Now, answer plus equal to whatever is the array of I value. Do we have an answer variable yet? No. So declare it before the loop. Answer equal to 0. And do I need to iterate until greater than or equal to 0? No, right? Not required to iterate until greater than or equal to 0. I need to iterate until whatever the values I need to consider. So what can I do? Since I need to iterate only until whatever values I consider, like we write for a for loop, we are going to write the similar condition, you can say. So consider minus minus is greater than 0 or not. So if consider minus minus is greater than 0, then you will take that value. Now, when will this get to 0? When you come across n by 2 values. When you come across n by 2 values, that is half of the values, you can say. This will get to 0 when you come across n by 2 values, and when you come to n by 2, your for loop will automatically stop. Now after this consider broke my loop, whatever are the leftover values, I need to iterate from them. So is there any other way that I can do the same thing simply? So I can iterate through the array. Likewise, I check my consider value. Now if my consider satisfies this condition, I'm going to add it to my answer. Once this stops satisfying my condition, that is once consider is equal to 0, that is I have considered all possible maximum values. Now whatever are remaining, I need to decrement, or I need to uh, subtract from my answer. So we can leave this as I greater than equal to 0 and handle this internally as consider minus minus is greater than 0 or not. Now if consider minus minus is greater than 0, I consider it into my answer. Else I make my answer minus equal to whatever is the array of I. Now, if you do not understand this, what other way you can do is first check if consider is greater than 0. If it is greater than, you're considering a value, hence decrement the consider variable. Both of them work fine. Now, finally, after executing the entire loop, we are going to have the answer in the ANS variable. So, I'll simply print my answer after my processing is done. Let's run the code first. Okay, so the expected output is 4, 0, 13 and 10, and my obtained output is also 4, 0, 13 and 10. Let's submit it. That's it, done. All right, let's move on to the next question. So, as far as I think, most people must have skipped this question because uh, you'll understand when we go ahead. So, you're given an array A containing n integers. Count the number of ordered pairs such that 1 less than equal to I, j less than equal to n, and a of I power j less than equal to a of j. That is, a of I raised to the power j does not exceed a of j value. Note that we are counting ordered pairs, meaning 1 2 is different from a pair 2 1. Now, he has not restricted the ij pairs. That is, he hasn't told that I should be less than j, or I should be greater than j, or I should be equal to j. So, you are open to assume I and j can be literally any values in between 1 and n. So, which makes 1 1 as an eligible value, 2 1 as an eligible value, 2 2 as an eligible value. All these are eligible values, you can see. Keeping these eligible values aside, so the input format and output format are pretty simple. He just wants us to return the number of ordered pairs that satisfy the given condition. So you might think a brute force approach for this could be, let's consider the case, second case 2 7 2 3. For every number, you can consider the pairs of every other number. I mean, consider the pairs with every other number. That is 2 7 as a pair, 2 2 as a pair, 2 3 as a pair. And likewise, remember whatever the ij we are talking about, those are indices. So what I mean by 2 7 as a pair here is, uh, here as well he has taken a1 a2 to an, which means one based indexing. So 1 2 3 4. So here the actual pair should have been 1 2, then 1 3, then 1 4. Likewise, you could also take 1 1, which makes your pairs in numbers as 2 2, 2 7, 2 2, 2 3. Like this, you can form how many total pairs? Since you're going to consider number of ordered pairs, you'll totally get n square pairs. That is with n into n minus 1 pairs. That is, with one number you can form a pair. Oh, sorry. That is, in total you'll get, for n, that is every index, you can perform this pairing operation to get n other pairs, which makes it n square total pairs. So ideally, your solution now should be taking n square for every test case. Now, if there are if there are t test cases, your time complexity would come out to be something like uh, t into n. Now your n's maximum value is given as 2 into 10 to the power of 5, and he also told that sum of n over all the test cases will not exceed 2 into 10 to the power of 5. So ideally what he means by this line is, most people must have ignored this line while reading it. Ideally what he means by this line is, whatever is the t into n, that is whatever the n you are going to get throughout all the test cases, it will give you a value of 2 into 10 power 5. So you shouldn't be assuming this as t's number of iterations, sorry, t's maximum values 10 per 5, and each of the n's maximum values 10 per 5 individually, which will give you 10 per 15 around the, I mean, the number of iterations is 10 per 15 around. But what he means here is the t into n value itself is going to be 2 into 10 to the power of 5. And now for each test case, you are going to make n iterations, which means another 2 into 10 to the power of 5, making it 4 into 10 to the power of 10 as your total iterations if you go for an n square solution. So if your number of iterations is above 10 per 8, ideally it is not expected to work fine. Now let's try to observe something in the given question. So in the given question, your array of I can go from 1 to 10 per 9 value. 1 to 10 per 9 value. Let's consider this example itself with a minor change. So assume the minor change to be, this is 7 and this is 1. Now see, what if in the given constraints your array of I is going to be minimum, that is 1. Now for 1, what would be the pairs that you would be forming? For 1 you can form 1 2 as a pair, you can form 1 7 as a pair, 1 1 as a pair, 1 3 as a pair. Now if this is I and this is j in each case, what would 1 power j be? We know that 1 power anything, let it be 1 to 10 power 9, any number, this is going to be 1. And does it satisfy this condition, that is less than equal to a of j? It satisfies for 2, it satisfies for 7, it satisfies for 1, it satisfies for 3. So for 1, every number satisfies this condition, can I say? Because he has taken equal to whatever is the aj you consider. If you consider j as I itself, you'll get the same value, and that is going to be same in this case. So I understood one thing, that whenever my a of I is 1, then my answer, that is whatever is the number of ordered pairs I'm going to maintain, how many times should it be incremented with? The number of ordered pairs formed by 1 is n pairs. So when I get a 1, I simply increment it by the value n, or here capital N. That is whatever is the number of numbers given to me. We have gotten one case with us. Let's dive into another case. Now apart from 1, if you look at a value, let's say 2, the next value, that is the next minimum value, 2. What is the maximum power of 2 that can come under this range? You see, the j is going to exponentiate. That's why I'm asking, what is the maximum power of 2 that can come under this range? The max power would be 2 power 30. And why it is 2 power 30 is, if you see 2 power 10 is 1024, if you consider that approximately to 1000, that is 10 cube, then 2 power 30 will approximately be equal to 10 power 9. Now, keeping this discussion aside, I understood that. Now, keeping this discussion aside, I understood that whatever is the value of a of I power j, can I say that it should definitely exist in between this range? Because my a of j is also going to be 10 power 9, and I'm going to consider this a of I power j only if it is lying in between this range. Now, for one, you identified that every number can form an ordered pair. The next minimum value 2, only its 30th power, you can say that it will take this range of values. That is, can I say that only the indices from 1 to 30 will give me the values in between this range? Because if 2 power 30 itself is going to be around equal to 10 power 9, or you need to think of it as greater than 10 power 9 actually. So if 2 power 30 itself, that is the next minimum value you can consider in the range itself, is going to give you a value greater than 10 power 9 in the first 30 indices. Now, why am I talking about 30 indices? Whatever are the indices, that will be my exponentiation value. If my first 30 indices itself cannot, if the 30th index itself cannot give me a value inside the range, that is, whatever are the array values I'm going to have, will I have any effect from 31 to whatever the 10 per 5 that he gave here? He gave that, 2 into 10 per 5 that he gave here. So the max value of n is 2 into 10 to the power of 5. I see that 30th power of the second minimum value itself is out of the range of whatever is the permitted given numbers to us. Now, will the 31 to 2 into 10 to the power of 5 powers of any number, let it be, will it come in the given range? No, right? It won't. It definitely will not. So, with this, indirectly, what do you understand? You can understand that for every number, I need to consider only 30 indices, and for these 30 indices, I need to check if it satisfies the given condition or not. And we understood clearly why I need to consider only 30 indices, because these indices are going to ultimately form a power of numbers, and that power of numbers is going to be considered against the array values again. So finally, I need to check for every number if there are any ordered pairs in the given first 30 indices. Clear? So according to that, if I mean, for understanding this, just give it a thought. What will happen if you have 35 or 40 numbers? So if you have 40 numbers, you know that the second minimum value 2 itself will stop giving a correct value at 30th index. Then whatever are the next 10 numbers, for 2 itself they are going out of the range. Now if 3 is your number, then 3 power something is going to be lesser than 30, because that 3 power something should be equal to 10 power 9. If you say whatever is the exponentiation value, that is, let's say 2 power 30 is approximately equal to 10 power 9, then 3 power x, which should be approximately equal to 10 power 9 or lesser than or equal to 10 power 9, the x value should be less than 30, can I say? Because the base increased, so the value is also, the entire value of this 3 power x is also going to increase, right? 2 power x will obviously be lesser than 3 power x. So x will get lesser than 30. Likewise, for 4, a lesser value, 5, an even lesser value, 6, an even lesser value. So the permitted range comes down to be very less if you consider only these 30 numbers. So it might seem a bit confusing initially, but when it comes to the code, you'll clearly understand it. So let's jump to the code now. Alright, so moving on to the code now. This is a usual input format. So int n equal to scan dot next int, and then int array equal to new int of n, and for int I equal to 0, I less than n, I plus plus, array of I equal to scan dot extent. For better readability, let's take it into a block. Right. So now I have my array ready with me. Now firstly I understood that for every number I need to consider the first 30 indices. So firstly to iterate through every number, for int I equal to 0, I less than n, I plus plus. Now the ith number is going to be our a of I. Now the permitted values of j we found out to be is the first 30 integers. So int j equal to 0, j less than 30, uh, j plus plus. As you can see, there is no guarantee that whatever is the n value is going to go up until 30. I can even stop even before 30 as well. So if that is the case, your range to be traversed or the permitted j values is not going to be always 30. Permitted j is going to be, if n is greater than 30, then you consider only 30. If your n is less than 30, then you consider n. So to make this happen, you can simply take math.min of whatever is the n value and 30. Now if you remember, we're using one based indexing, and whatever number I considered, that is 30, was including in the range. So ideally j should go until permitted j, and it should be less than equal to, and since I am following one based indexing, I need to start from 1.
Now, where will my jth number be? It will be at array of j minus 1 position, right? It will be at array of j minus 1 position. So I need to compare what value with this array of j minus 1? I need to compare a of I power something. So math.pow will give me a of I power something. And what is that something going to be? A of I power j, as he has given the question. So this will be my power value, or let's say aij value, ai power j value. Now I need to check if this aij value is satisfying the condition aij less than equal to array of j minus 1. If this satisfies this value, what do I do? I need to simply increment my answer. Now if this does not satisfy, do I need to care about it? No. But also one more thing to be made sure of here is, we told that whatever is the value that let's say 10 power sorry 10 itself as a power I. Now for 10 I only need to go until j as 10, right? At 10 itself, 10 power 10 is going to give me a value greater than the given range of numbers, that is greater than 10 power 9. So when I get a number 10 power 10, do I need to go further with this j? If I increment my j to 11, 12, 13, I'm going to get even larger numbers. So if my value aij is greater than 10 power 9, then I need to simply break my loop. I need not search for my eligible pairs anymore. Now, a simpler way to write this 10 power 9 is, Then
This for we are doing this for numbers array of I, and this array of I only if it is not equal to 1. Now if it is equal to 1, what do I do? If my array of I is equal to 1, whatever are the other numbers including 1 will form an eligible pair. So answer should be incremented with n, that is all the numbers. Else, that is if my array of I is not 1, then I perform this logic. And finally, what do I do? I need to print my answer. So where do I print my answer? My for loop is ending over here. So system out print answer. Let's see. Okay, what is it? We missed a semicolon. Semicolon at line number 28. Done. Okay. A of A of lossy conversion from double, that is the value returned from the power function is double, we are trying to convert that to an integer. So let's take a double itself, or the other way is converting this number to an integer. But remember that integers range is roughly up until 2 into 10 to the power of 9. So if my value is going to go out of the range, then I'm going to get some garbage value. So even if my value is greater than this 2 into 10 to the power of 9, I need to somehow store it. So what can I simply do? I can take it in a long variable, long. With this, I can say that my aij value is always going to be aij value is always going to be in the range. So answer plus plus, that's it. Alright, what is expected output? The expected output is exactly the same. So let's submit it. Wrong answer. Okay, so what could this wrong answer be led to? Now, whatever approach we discussed, it is almost, or I can definitely say that it will be correct. So, where could I go wrong? In such cases, just observe the constraints. Now, in the constraints, he tells that n can go up until 2 into 10 to the power of 5, and ai can start at a value of 1 and go up until 10 to the power of 9. What was my case if my value was 1? The entire array, the entire length of the array should be added to my answer. Imagine if all my 2 into 10 to the power of 5 elements are my 1, then my n, if my n is 2 into 10 to the power of 5, then my answer will be this n added how many times? N times. So answer is also going to be 2 into 10 to the power of 5 into 2 into 10 to the power of 5. If this is the case, then what turns out to be my range of my answer? My answer can be even 0 maybe, and it can go up until 2 into 10 to the power of 5 into 2 into 10 to the power of 5, which makes it 4 into 10 to the power of 10. I already told you that int's range is going to be 2 into 10 to the power of 9 at most. So to store this, what do? I simply change my data type of answer to long. Now this will ensure that my answer is kept a track of. Correct answer. So this is one important reason that you need to make sure you are looking at the constraints very keenly. Also, a few improvements here are, now you understood this, and if you understood this, now what will the value of area of I, okay, what will the area of what will the value of aij be if my area of I is 2 at j equal to 1? It will be 2. When j is 2, it will be 2 power 2, that is 4. When j is 3, it will be 2 power 3, that is 8. When j is 4, it will be 2 power 4, that is 16. So can I say that in each step, I am going to get the value as into 2 of the previous value. Here, since my area of I was 2, I am going to get into 2 value. If my area of I was 3, into 3. So ultimately what will be here? If let's say your long x, we already understood that this value can go up until the range of long. So long x. Now when j is 1, what will area of I power j be? Simply area of I. And now in each step, where can I find your aij now? This is max value of int. So where can you find the aij now? It is nothing but the value of x. Now after I have utilized x for j equal to 1, I need to make it ready for j equal to 2. That is area of I square. So what can I do? X is equal to x star area of I. This will make sure that I am multiplying my x value for j times until the permitted j value. And here as well I need to check for x. So what are we doing? We are not making use of the math.pow function, and we are trying to find the value of to find the value of a of I power j on the fly. So let's see if this works. That's it. So we removed one, what do you say, an unwanted use of a function, an inbuilt function, that is POW function here, and we simplified our logic. So that's it. Let's move on to the next question now.
The next question, ABC conjecture 3. So you are given a string S of length n containing of characters A, B and C. So he says that S of I is going to belong to A, B or C. It will not be any other characters. Now in one move you can modify S as follows. Choose three indices ijk such that they follow this condition, uh, and Si equal to A, Sj equal to B, Sk equal to C. That is, choose some subsequence. Now a subsequence is nothing but a contiguous or a non-contiguous part of an array or a string uh, that maintains the insertion order. So you'll understand what is a subsequence while we get deeper into the problem. You can then either delete an A or a C. That is, you can either delete the index I or K. Note that this reduces the length of S by 1. For example, you are given a string C, B, B, A, C, B, A, C, C. Let's consider an even simpler string CBA CCC. Yeah. So in this given string, now what can I do? The indices or the subsequences I can pick is ABC, and where the indices chosen should be A, B, C, such that the indices chosen are I, J, and K. Note that he told Si is equal to A. So I chose an A as my ith index, then B as my jth index, then C as my kth index, and I see to that this ijk is going to be increasing order, and they are not even equal to, it is a strictly increasing order. Here as well, he has gone for a one based indexing. So this is one possible pair, one possible subsequence. Now in the subsequence, after choosing, I can either delete an A or a C. Now what happens if I delete an A? A as in the A at the ith index. So the string formed would be CB, A won't be here, C, B, A, C, C. Then if I remove the kth index, let's say, that is if I remove the C, if I remove the C, I'm going to get CBA, CBA, C, where one C has been now removed. So this is when you remove ith index, and this is when you remove the kth index. You need to find the minimum number of moves that can be made on S such that it's impossible to perform any further moves on the resulting string. So if you observe, if I remove the ith index, am I able to perform any more operations here? That is, first thing is I need to choose ABC. Can I choose a subsequence ABC from this given string? I mean from this modified string? No. Whereas here I can form one more subsequence A, B, C. So what can I do? Here I can perform one more operation. Whereas here I can no more perform any operations. He needs us to find minimum number of moves to make our string in such a condition that I can perform no more operations. That is impossible to perform any further moves. So ideally, now here what could the other move be? I can pick this ABC. The other move could be removing this A, which means CBCBAC will be my string. Or if I remove the C, I'll get CBA as my string. So in both of these cases, I cannot perform any further operations, but the minimum possible moves that can make my string go to this condition is by directly removing the ith index. Hence, answer comes out to be 1 for this string. So, what can I simply do? Now, at this point, let's consider case by case to solve this problem. So, initially, let's consider a simpler string A, B, C, C. If this is my string, if this is my string, then what would be the operations I would perform? Simply, with this B, these three A's along with this B with these two C's can form subsequences. So if I either remove these C's or if I either remove these A's, wouldn't that make it sufficient for my string to perform no more such operations? Yes, right. So one of the first moves could be picking this ABC, deleting this C. Then the next move could be this time only a single C, A, B, C, again delete this. Or vice versa, I can pick uh, different A's and delete all the A's. So if I pick different A's and delete all the A's, my moves for deleting all the A's would be 3, or if I delete only the C's, I'd get 2. And I need to find minimum number of moves to make it attain the condition. So here the minimum number of moves is obviously 2. So what do we understand by this? By this we understand one point clearly, that if my number of B's in the string is 1, then I need to delete either all the A's occurring before it or all the C's occurring after it. We'll discuss how to implement this later, but let's concentrate on the approach here. One thing is clear, that if there is a single B, then this is going to be my plan of action. So let's keep this aside for some time. Now, the next case is, let's say I have the string as AAC or CCC or ACA. If this is the case, what does that mean? I do not have any number of b's. So if the number of b's in my string is 0, then can I firstly form a subsequence ABC? No, right? So if my number of b's is 0, then my number of moves is also going to be 0. Here 2 is our answer. Here if my number of b's is 0, then my answer is also going to be 0. Now we have seen a case where I got no b's, then I got one b. Now what if my string contains two b's? So let's consider a simple example, a b c a or a c b, uh, a c b, a c c. Now in this case, what do I do? So one possible way is, I can see that this a is going to form subsequences with either this b or this b. Now, if my A is going to form a subsequence with this B, then I need to have C's after this B. I need to have C's after this B. That is the first B I consider. Only if there are C's after this B, I can form subsequences. So, to make it not form a subsequence, what can I do? I can delete these C's. But is 3 our answer in this case? Our answer could be optimally, it could be removing this A because this is forming subsequences from here, then removing this A which is forming subsequences from here, and after this if I remove these two A's, let's say I remove this first A and this second A, if these two are going to be removed, then can I form any more subsequences here? No, right? So ideally our answer should be 2. But what is our answer here? 3. So how are we going to get this A and this A? And why are we ignoring the last A? If you observe, this is nothing but the A's before the last B. And these are nothing but the C's after the first B. So one possible case or one possible plan of action could be, if there are two B's or more number of B's, let's say even if there is a B over here or somewhere in between the string, even if there is a B over here, if there are no A's to fulfill this or no C's to fulfill this at the first and the end, then my string cannot be forming any subsequences. So if there are two B's or more than two B's, what would be my plan of action? I firstly consider the number of C's after first B, then I consider number of A's before the last B. After considering these both, I need minimum of these two. That's how the minimum of 2 and 3 came out to be as 2 as my answer here. So this is my another case where I need to find the output like this. Let's move on to the next case. Now, what if your case is with two B's, but like this, that is A, B, C, A, C, A, A, B, C. If this is your case, what do you do? So, like we did for if there are two B's or more B's, we can do the same thing, you might assume. So, what do? You need to first find what is the number of C's after this. What is the number of C's after this, which would be 3 C's. And what is the number of A's before this, which would be 4 A's. Ideally, for this case, what would the answer be, and what are we getting as the answer here? The answer would be, as per our approach, 3. But what is a simpler answer here? So if you think logically, this A is the only thing that is forming subsequences from there on with this C or this C or this. Likewise, this C is the only C that is letting a subsequence be formed by these A's or this A or this A. So the culprits are the first A and the last C. If there were more A's here or more C's over here, then what should I do? I simply need to delete all these A's and C's that are occurring in the first and the last, because in between these two B's, if these two B's are continuous, I can see that there cannot be any subsequence formed. And is it only being continuous that is a B after another B? Now, what I mean by continuous is there can be characters, but there is no other B in between. That is, if there is this B over here, then you need to consider it differently. But if there are only two B's, then we need to consider the two B's and what are all the A's and C's that are outside these, uh, and they should be removed. So ideally, you can assume that we are considering these two B's and all the characters in between them as a single B, you can say. So at this point, if you do that, what will be your answer? Your answer will be 2. So your 3 or 4 could also be a competent for your answer. But your actual answer comes out to be 2 if you understand the fact that if there are two B's such that there is no other B in between them, then there cannot be any subsequence formed in between, and there will be the subsequences formed only by A's before the first B and C's after the last B. Or here, since we are considering only two B's, the second B. Because if there are multiple B's, then this can also come into picture. Now let's see how to apply the same fact to other cases where I can find multiple B's. So let's keep this aside as well. Now, what if my given string is something like an extension to the previous string A, B, C, A, C, B, A, B, C, A. Yeah, let's just copy down this C, A, B, C. So you can say that this is almost the previous string. Yeah, almost the previous string, and this is the adjoint new string, you can say. Now, with this string, let's see what happens and how are we going to perform the operations for multiple B's. So until now, you should have understood the fact that B is the deciding factor here. The B is going to be the deciding factor of how many moves I'm going to make. Now, we know that for any two B's such that there are other characters in between but not any B's in between. If I remove all the A's occurring before the first B and all the C's occurring after the second B, then I'm going to get my string or my final set of moves. So if this is the string I need to consider, sorry, if these are the two B's I need to consider, I'll simply remove this one B before it. And how many C's should I remove? After this b, I can find two c's, so plus 2. And what do we do with next b's? So for the upcoming b's, we are going to apply the same fact and see which might be the best possible pair of b's I need to take. Now, for the next possible pair of b's, what would be my answer? And how am I making this decision? I am sure that if I pick any two b's such that there are no more b's in between them, then I can only form subsequences by a's before the first b and c's after the second b. So if I pick these two b's, then what is going to be my answer? The number of a's before the first b is 2a's, and number of c's after the first b is 1 2 c's. Now what comes out to be the next couple of b's? The b over here along with the last occurring b in my string. So for these couple of b's, again I know the fact, and based on the fact I am going to remove all the a's before the first b and all the c's after the last b or second b. So here 1 2 3 3 a's to be removed, and 1 c to be removed. uh, yep, 1 c to be removed. Among all these, which is the best couple of b's I need to choose such that I get an optimal answer? It is nothing but going to be the first pair of b's, can I say? Right. So indirectly, what are we finding? We are finding the best couple of b's that can get me to a solution where I cannot, that can get me to a string where I cannot form any more subsequences to perform the operations or moves. So I hope it is clear. Uh, how are we going to firstly perform this? At every point, can I say that I need to know how many A's are there before any BA consider and how many C's are there after any BA consider? My overall trick here is to find what are all the B's, and for every B I need to know readily how many A's are before the B and how many C's are after the B. So for such a case, what you can use is you can maintain a prefix array that keeps a track of what is the number of A's occurred until that ith index. Likewise, to keep a track of C's after any index, you can simply maintain a suffix array. So these two are going to keep a track of prefix, to keep a track of A's before an index. Likewise, suffix array is going to keep a track of C's after an index. With this, can I say that I can readily get what is the number of A's before an index and what is the number of C's after the index? Yes. So one part is done. Likewise, I need to know where are all my B's occurring. So I can explicitly perform another loop where I iterate through every index, and whenever I find a B, I can put that inside my list of indices where I'm keeping a track of where all did B occur. So here totally three parts are going to be there: the array list, the list which keeps a track of B's indices. Alright, now moving on to the code. Firstly, I need to know the prefix array and the suffix array. And even before that, I need to scan my input. So int n equal to scan dot next int. That is, here the first line is going to be the size of the string. Sorry, the first line is t, which we have already scanned using the template I have taken. Then I took n. Now after the n is taken, that is the size of the string, I need to know what is the string. So string s equal to scan next. Now with this I have my size of the string and string ready. All I need to know is firstly the prefix array and the suffix array. So int, both are going to be arrays. So int array prefix a equal to new int of type, new int of length n, because for every index I need to keep a track of what is the number of a's before the index. Likewise, suffix of c equal to again new int of n. Now after I have my prefix and suffix arrays, what do I do next? I need to fill in the arrays. So to fill in the prefix array, you usually start from the left index, that is 0, I equal to 0, I less than an I plus plus. Prefix a of I is going to be prefix a of I minus 1 plus. Now when do you add 1 to your prefix array's current index? When your current index character is a. So you need to check if the current index character is a, which you can do it using ternary operator. uh, so s dot caret of I is going to get you the character. You compare it with a. Now if it is a, you need to add 1 to your prefix. If it is not a, then you add 0 to your prefix. And likewise, this prefix a of I minus 1, if you assume for index I equal to 0, you're not going to get the prefix a of minus 1, right? So to handle that, you can also use another ternary condition here. So a ternary condition, if I is equal to 0, if I is equal to 0, what do you consider as your prefix? Until now you haven't seen any indices, so at I equal to 0 you can consider 0 as your prefix, else prefix of I minus 1 as your prefix. Now with this, my prefix a of I is going to be filled, and once it is filled, next I am going to fill my suffix array. To fill the suffix array, I simply can start from the last index n minus 1, and I should go up until 0, I minus minus. Now, like for prefix, my suffixes condition is going to be almost same. Okay, I'm not sure why it has indented this. Okay, so suffix here, instead of prefix a, you will take suffix c, and since you are starting from n minus 1 and suffix builds on I plus 1th index, that is from the plus 1th index you get the suffix value, and to that you add something if required. Now if you are going to get I plus 1 here, if you're going to get I plus 1 here, when your I is n minus 1, then what will your I plus 1 be? N. Can you get your nth index? Your max index itself is n minus 1. So here you need to check if I is equal to n minus 1 or not. If I is equal to n minus 1, you consider 0 as your suffix, else you consider suffix of I plus 1th index. And here the character to be considered is C. So if your current character is C, then you add 1 to your suffix, else you add 0 to your suffix. Now with this, my prefix array and suffix array are ready. Next, let's move on to a loop to get the B indexes. So I plus plus array list is going to store my list of B indexes, array list AR or B position, you can say. Let's take it as AR itself. New array list. This is going to store our B's positions. So this is going to store our B's positions. Now if my current character, that is s dot caret of I, is equal to B, then this adds up to my array list. So ar dot add I. If you remember, we have the work to be done with indexes, not the b or I mean not the character value. I mean you consider the character value, but apart from that, the index also matters much. And according to the approach we already discussed, we need to store the indexes. Now, if your b's positions array list is empty, what does that mean? It means that there are no b's in your given string. So if array, that is array list dot size, is going to be equal to 0, then what would your answer be? Simply 0, right? Let's take an answer variable. Now my answer variable should be as minimum as possible, hence I'll take this as integer dot max value. Now, if my array dot size is equal to 0, my answer also becomes 0. Else if, what was my other case? If my array dot size is equal to 1, if it is 1, it means that I have a single b. Now I need to know at this b how many a's have occurred until there and how many c's will occur after that. Do I have a way to get this how many a's occurred until there and how many c's going to occur after that? We have our prefix a of I, which tells me how many a's are going to occur before that, and we also have the suffix c of I, which will tell me how many c's are going to occur after that. Now when your number of b's is 1, what do you simply do? You'll remove either these a's or these c's and you remove the minimum of them. So math.min of prefix a of I and suffix c of I. Prefix a of I gets you how many a's have occurred until then. Suffix c of I gets you how many c's will occur after that. So answer is equal to math min of this. Now else, this is where you start with your pair of b's logic. And how are you coming to that conclusion? You know that if there are a pair of b's such that there are no more b's occurring in between them, then you cannot form any subsequences with the values in between them. If you remove all the a's before the first be considered and all the c's after the second be considered. So here you are going to make use of the array list of b indices you have taken. So you need to consider every ith and I plus 1th index of the array list. Hence int I equal to 0, I less than array dot size. Since we are going to access I and I plus 1, your I should be ideally array dot size minus 1 and I plus plus. Now your first b you have considered is, or first b's index you have considered is array dot get of not 0 I, and the second b you have considered is array dot get of I plus 1. This is going to get you what is the first be considered, what is the second be considered. Now in between this you cannot form any subsequences if there are no a's before the first b and no c's after the second b. So how do you get what are all the number of a's before the first b? The number of a's before the first b is simply prefix a of first b, and the number of c's after the second b is suffix c of second b. Now summation of this value will give you the total number of characters that you need to remove. The total number of characters that you need to remove is nothing but the number of moves you make. So this will be a competent for our answer. And for every such pair, you are going to minimize your answer using math.min and assigning this to answer. So pre a of first b plus sub c of second b will tell you how many characters to be removed or how many moves to be made. You take it into the answer, considering it as minimum of answer, existing answer and the current answer. Now, apart from all this, we also discussed a case where this might not be necessary. That is, you simply need to remove all the C's after the first B, or all the A's are before the, sorry, yeah, all the C's after the first B and all the A's before the last B. So that is one more way out. Hence, uh, you have the first and last B's. I mean, you'll have the first and last B's only if your AR dot size is greater than 1. So here itself, you can take your answer to be minimum of all the A's after the, sorry, all the A's after the last B. That is pre-A of last B is at the index AR dot get of AR dot size minus 1. And likewise, you can also remove all the C's after the first A, sorry, after the first B, that is sub C of AR dot get of 0. Why are we doing this? AR dot get of 0 will hold the first B position, and AR dot get of AR dot size minus 1 will get you the last B position. Pre-A of this value will get you how many A's are occurring before the last B, and sub C of this value is going to get you how many C's are occurring after the first B. So after this, after all this, you finally will print your answer. Your while t loop is ending over here. So system out print ln answer. I understand that it is a big logic, but yeah. So we missed this semicolon over here. Let's see. Okay. Okay. So yeah, bad operand types for binary operator plus, right? So what it is trying to say is basically it passed from left to right. That is, when passed this, it is going to take that as the condition because you mentioned it inside the bracket. So it evaluates the condition and tries to add that to an integer value. So whenever you use a ternary operator, try to enclose the entire expression inside the brackets. So that will help in processing without any errors. Okay, wait, cannot find the symbol pre of I of C of I in the line 35. Okay, I, we have taken I. Oh, my bad. So yeah, if your array dot size is equal to 1, that is there is only one element in your array list, and it will be at the 0th position. My bad. It will be at the 0th position of your array list. So this will get you how many A's are before that B position, how many C's are after that B position, and math.min will give you a minimum of these values. Mm, yep, that is exactly same as the expected output. Let's quickly submit it. That's it. All right, guys. So I would like to give you one more hint to the better solution. So instead of taking in all the B's and taking in what is the count of A's and C's before and after every position, you could try an even better approach, such that you can get an answer in a single traversal itself. So try to get that approach, and if you solve that approach using the single traversal thing, and that involves, okay, let's just give a hint, that involves storing the number of A's, B's, and C's. You can say, so if you get this approach, uh, comment in the comment section that done using the linear approach, or a simple done would be sufficient. Yep. Right, guys. Hope you liked the video. Smash the like button and subscribe to Smart Interviews for more such content. Yeah, thank you. Arun signing off.